Hello, everyone. Welcome to Lesson 4-1, How the Internet Works. Whether you're browsing social media, sending an email, or watching YouTube, you're using the Internet. But how does it all work behind the scenes? Today, we'll explore this invisible, global system in a way that's simple, intuitive, and relevant, especially for those who create or influence policy. Let's begin with an analogy. Imagine the Internet as a global transportation system. Just like we have roads, cars, traffic signals, and delivery trucks in the real world, the Internet has cables, data packets, routers, and protocols. When you send an email or visit a website, it's as if you're mailing a letter or driving to a store, but in the digital world. Now, here's something crucial to understand: the Internet is not a single machine. It's a network of networks, millions of computers, smartphones, servers, and data centers all over the world, connected through physical cables, wireless signals, and satellite links. Before we go further, let's clarify a common confusion. People often use the terms Internet and web interchangeably. But they're not the same. The Internet is the infrastructure. It's like the roads and tunnels. The web, or World Wide Web, is just one of the services that uses that infrastructure. It's like trucks delivering online content. Other services running on the Internet include email, file transfers, video conferencing, and messaging applications. So, the web is a big part of the Internet, but it's not the whole thing. Now let's break down some key components of how the Internet functions. First, IP addresses. Every device on the Internet has an IP address, which stands for Internet Protocol Address. You can think of it like your home address. It tells the Internet where to send information. There are two versions of IP addresses. IPv4 is the original format, but it's running out of space. IPv6 is the newer version, with almost infinite possibilities. For example, a typical IPv4 address looks like 192.168.0.1. An IPv6 address might look like 2001:0DB8:0003:000:000:000:00370:7334. Every website, smartphone, and even smart fridge has an IP address. Next, the Domain Name System, or DNS. Since humans aren't great at remembering long strings of numbers like IP addresses, we use domain names like google.com or tokyo.jp. The DNS works like a phone book. It translates those human-friendly names into machine-friendly IP addresses. So, when you type a website like www.nhk.or.jp into your browser, the DNS finds the matching IP address, and your browser connects to the correct server. Let's now talk about how information travels across the Internet. When you visit a website or send a message, your data doesn't travel as one giant file. Instead, it's broken into small chunks called packets. Each packet contains a piece of your data, along with your IP address as the source and the destination IP address for where it's going. These packets travel through the network independently, often taking different routes. When they arrive at their destination, they're reassembled into the original message. This is similar to putting together pieces of a puzzle. This process is called packet switching, and it makes the Internet fast, flexible, and reliable, even if some routes are busy or temporarily down. Now, who decides where these packets go? That's the job of routers. Routers are like smart traffic controllers. They decide the best path for each packet to reach its destination. You'll find routers in your home Wi-Fi box, in your local telecom office, in undersea cable stations, and at major internet exchange hubs in big cities. These routers are managed by companies called Internet Service Providers, or ISPs. Companies like NTT, SoftBank, or AT&T connect your home or office to the wider Internet. And yes, despite how digital it feels, the Internet is mostly physical. Over 99% of international data travels through undersea fiber optic cables. Satellites are used too, but they are slower and mostly reserved for remote areas. Let's walk through a simple example of what happens when you type a website address into your browser. Say you type www.nikkei.com first, your device asks the DNS server to translate that domain name into an IP address. Second, your browser forms packets requesting the home page. Third, those packets are sent to your ISP's router and travel through the internet by hopping across multiple routers. Fourth, the Nikkei server receives your packets and sends back data packets with the requested content. Finally, your browser reassembles those packets into a readable web page. And all of this typically happens in under 1 second. Let's now look at two common models of communication on the internet. First is the client-server model. This is the most common model on the web. In this model, your device, such as your phone or browser, acts as a client. It sends requests to a central server, which stores and delivers data. For example, when you visit Google, your browser is the client and Google's server responds with the information you need. This model is centralized and easy to manage. Second is the peer-to-peer model, often called P2P. In this model, devices act both as clients and servers. They connect directly to each other. This is commonly used in file-sharing systems like BitTorrent, in cryptocurrency transactions, and in local mesh networks. P2P systems are decentralized. They're harder to control, but they're also more resistant to censorship and failure. Now let's talk about why all of this matters, especially to policymakers. The internet is not just technical. It is also political, economic, and social. Understanding how it works can help you make smarter decisions. First, infrastructure investment. Governments play a vital role in expanding rural broadband, funding public internet access points, and supporting affordable connectivity for low-income communities. If we consider the internet a public good, then ensuring access for all becomes a key policy goal. Second, regulation. From net neutrality to content moderation, policy decisions shape how the internet operates. For instance, should internet providers be allowed to charge extra for faster service? Or should DNS activity be monitored for national security reasons? These are questions that require a basic understanding of how the internet moves data. Third, digital inclusion. Many communities, especially the elderly, the disabled, and the economically disadvantaged, are being left behind in the digital revolution. Knowing how the internet works helps policymakers design inclusive programs for e-government, online education, and digital health. Let's not forget that most of the internet is invisible to us. You don't see the fiber optic cables buried underground. You don't see the server farms in places like Iceland. You don't see the algorithms managing data flow. And you definitely don't see the DNS root servers that anchor the entire system. But just like a city depends on its electrical grid, water supply, and road network, the modern world depends on this digital backbone. Let's conclude. We've covered a lot today. You now understand